Hello guys and welcome back to my channel Interview with Bunny, and today we are back with another video on system designing playlist. And the system or the topic that we will be discussing today is another important topic for the system designing interview, and that is rate limiter. But before starting with the designing of the rate limiter, I just want to give you a small heads up. That is, in my career I have given a lot of interview on the product based companies, and there are a lot of time I have faced this same question, that is, do the system designing of a rate limiter. And particularly for this question, I have seen that the interviewer will ask you to write the code. Means what we normally do, that during the system designing or during the high level round, we only try to design the application with the help of what are the services or the modules that are needed and how they will be interacting with each other. But for this question, once you are done about explaining that how a rate limiter actually works, what are the principles or the algorithms that are associated with the rate limiter, thereafter the interviewer will ask you to write the code of that algorithm following the object-oriented design pattern, like strategy design pattern, observer design pattern. So whatever the design pattern we have, based on that, whatever you feel that is appropriate for your designing, for the implementation of the algorithm, you have to give the complete running code on the compiler. So that is actually the ask for this question. So it is not like other system designing question that you will simply tell the architecture and you will be done with the designing. Rather, here you have to do both of them. That is, first you do the designing and then you have to write the code to give a complete idea of the rate limiter to the interviewer. So keeping this thing in mind, let's start with today's topic, and that is designing of the rate limiter. So let's start with the first step of our designing, and that is the gathering of the functional requirement. So as you know, a rate limiter is nothing but a service or an application that actually blocks the number of requests of the user if it goes beyond a certain limit. So for example, you are designing an API for the ChatGPT or Gemini, and your use case is you are giving the user the provision to generate the image. Now, since here in the backend you are using an LLM, which is actually a costly transaction, you cannot give the user to use your API beyond a certain limit. So to put a restriction or put a control on your backend service, we actually use a rate limiter. So for example, for a particular user, only 15 requests can be done per minute for the generation of an image. In this way, there can be multiple number of use cases or restriction that we can create with the help of this rate limiter. So that is actually what our rate limiter actually does. So now, since you have an understanding that what is a rate limiter and what it actually does, now it will be easy for you to understand that what are the functional requirements we will be going to solve over here. So the first functional requirement of the rate limiter is very straightforward. That is, we should limit the number of requests of the client. And this limitation of the restriction can be implemented by many ways. So for example, we have to limit a client based on the user ID. So for example, a particular user ID should not have the access to a particular database or a particular API for more than 10 requests per minute, or the restriction can be with the help of an IP address, or it can be API keys. So there are multiple key factors or multiple attribute or parameters by which we can put a restriction on a particular resource. So our first functional requirement is we have to limit the number of requests for the user. Here, now the second requirement is all these rules by which we are restricting the user should be configurable at the runtime. Means it should not be a static figure, rather a configurable or a config driven approach by which the admin can change the number of requests of a user or anything. Means all the rules of the rate limiter should be configurable by the admin. Clear? Now the third requirement is whenever the limit exceeds for a particular user or particular client, what we have to do, we have to give a meaningful response to the client. And really what we do, we give a HTTP response of 429. Now the fourth requirement is very important, and that is we should be able to handle the burst traffic of the client. So as you know, during the particular sale or anything, there you can easily expect a burst amount of traffic from the client. So all those type of peak traffic and everything should be handled by our rate limiter. Clear? Now once we will be discussing different algorithms of the rate limiter, it will be very easy for you to understand that what this burst traffic actually means and how you should be handling all these things. Now comes to our last and the fifth requirement, that is we also have to support based of the application tier. Means for example for ChatGPT, as you know, we have 4 tiers. Number 1 is a free subscription or a free tier. Number 2 is the Go, which is an $8 thing. Post that we have a plus membership which have $20 subscription. So there can be different tiers on an application, and based on each and every tiers, the configuration of the user or the rate limiting also changes. So we have to also support this type of feature. So I hope you are clear with what are the main 5 primary functional requirements that we will be supporting over here for our rate limiter. So let me first list down all these functional requirements so that it will be easy for you to understand. So these are all the 5 functional requirements that we have to fulfill in our designing. Clear? Now let's move to our second step of our designing, and that is gathering of the non-functional requirement. So the first and the foremost non-functional requirement that you have to ask your interviewer, and that is the scale of the system. And since this is our rate limiter, means all your traffic should go with the help of this rate limiter. So it is very much expected that the amount of the peak traffic or the scale of this system should be very high. So here the scale of the system, we can easily assume that around 1 million requests per second. Now the next non-functional requirement that we have to discuss with your interviewer, and that is very important, and that is cap theorem. And as you know, cap theorem tells that whenever you are creating a distributed architecture, it is not possible for a particular module to be highly available as well as highly consistent at the same time. You can achieve either of them. So it can be only highly available or it can be highly consistent. But based on the use case on the rate limiter, you can easily understand that our system should be highly available rather than highly consistent. Let me explain why I am telling that we should give the priority to the availability rather than consistency. Because of the fact, for example, our application is down for some time, and since the rate limiter is the primary gateway for any request, so if our application is down by anyhow, all the requests that are coming into our service will get lost, and that is why our system should be highly available rather than consistent. And whenever I am telling consistency, it means that since this application can be customizable, means the rules or the everything can be configured on the runtime, it is fine that once the admin make a change on a particular rule, it is totally fine that after a minute or so the rule get propagated on all the rate limiters. So that is completely fine, but the downtime of the rate limiter is actually not accepted. I hope it is clear that why we should give the availability more than that of the consistency. Clear? Now let's go to our third non-functional requirement, and that is the latency of the system, and which is the crucial part over here. And here our application or our process should have an ultra low latency, means it should resolve everything and it should determine that whether a particular request should go to the backend or not within 5 milliseconds. Otherwise it will create a huge lag to the entire backend system. I hope we are clear with what are the major 3 non-functional requirements we have to fulfill by our design. Clear? Let me first write all this thing. So here if you look carefully, we have successfully gathered both the functional and the non-functional requirement of this system. Now let's go into our second step of our designing, and that is the identification of the code entity. Means what are the major entities that are related to the rate limiter. And as I tell you in all my video, identifying the code entity is actually very easy if you just read through the functional requirement properly. And here if you look carefully, the code entities that we can figure it out right now just by reading the functional requirement are: number 1, the configurable rules, means the configs per user or per client. Number 2, the clients which are actually interacting with our service. And number 3, the request counter, means so for example, a particular user is hitting our API n number of times. So we have to keep a track of the total number of time the request have come from the client. So we have to keep track of both the things, means the total limit that was set for the user and the total number of times he have already hit our API. So there are 2 variables or the 2 property that are the 2 most important code entities for this system. So let me list down all the code entities that we have figured it out right now just by reading the function requirement. So these are the three primary core entities, that is the rules or the config, number two the client, and number two the request counter. I hope this is clear. Now let's go into our fourth step of our designing, and that is the API designing. Now as I tell you, before going into the third step, and that is the API designing, discuss with your interviewer that whether your interviewer is interested to know that what are the REST endpoint we have to expose for this application or not, because this is actually a very time consuming job, and listing down all the API endpoint within the 45 minutes time window is actually pretty difficult. So first discuss with your interviewer whether he is actually looking for this or not, and if he is not, just skip this step. But in case he wants to see that what are the major endpoints that are required to invoke all the service or how the client will be handling with our system, then you have no other option than to list down public REST endpoint that you have to expose for the user. So let me list down all these endpoints over here. After that, I will let you know what is the use case or what are the function requirement that is actually it is solving. So here you can see these are the three major endpoints that you have to expose for the admin. So since our rate limiter is not something like a product or anything that the client is actually hitting, so we do not have to expose anything directly for the client to hit our API or hit our application. Rather, since it is a process or an application that is used by the application internally, so these are only the three internal API endpoints that we have to expose for the admin to change the configuration. So as I was telling you, we have to fulfill the requirement that all the configuration should be able to change on the runtime. And to facilitate all these things, obviously we have to expose some API endpoints so that the admin can change all those values or all those configurations. So let's see what are the endpoints we have to list over here. So the first one is the create rules, means by which for a particular user or a particular enterprise we should be able to create the rules for the enterprise. Number two is the get API, by which giving the client ID we can retrieve the value or the configuration that we have saved in the database. And the last one is for the dashboard creation or for the internal audit purpose. So this is nothing but an admin API just to find out the metrics for a particular URL. So these are more or less all the three API endpoints that are required for designing this application. But there is one more thing that is very important and your interviewer might ask, that is, what will be the response of the rate limiter? Since rate limiter is something that is blocking the client, we also have to give some meaningful response to the client that what is the actual thing that is blocking the user from using the application. Because if we do not give a meaningful response to the client might think that it is some defect in our system which is actually blocking the user from using our application. So our response of the rate limiter should be meaningful, and there is a particular template by which the response of the rate limiter should come. So let me share that template or how the rate limiter response in the production level or in the general purpose application. So this is how the response of a rate limiter actually looks like. So here you can see we are giving a status code of HTTP 429 as the response. After that, in the response body, we have to give some important parameters or important attribute, that is, what was the limit that was set for a particular user, what are the remaining number of requests the user can do, then when this value will get reset, and all those things. So these are some technical data that we actually send to our client or to our invoking service to get an idea that what was the actual cause and after what time user can use back our application. So if you see in ChatGPT, when you are exhausted with your daily limit, it will show you that after a particular time instance, you can use the ChatGPT again. So this is nothing but the limit that we are sending over here, means we should retry after this amount of time. So this is basically the template or the response which the rate limiter should send as a response to the request. I hope this is clear that what will be the core entities and how we will do the API designing of the rate limiter. Now let's move to our next step and probably the most important step, and that is the high level designing of our application, where we will actually see that what is rate limiter and where this application belongs. So all these things we will see or we will discover in our next step of our designing, and that is our fourth step, that is the high level designing of our application. So the high-level designing of the rate limiter is very easy, because the rate limiter, though a crucial thing for a particular application, but the structure or the architecture of the rate limiter is not that massive that it is too complex to design. But the first and the most important thing that we have to understand that where this rate limiter actually belongs. So just to understand this thing, what I will do, I will just draw a very high-level diagram of a microservice architecture, means some of the backend and the front-end application on all this thing. And after that, I will let you know where this application will belong. So as you know, for any microservice or any application that we have right now, have three major components. Number one is the clients who are using our application. Number two, the backend service which are actually fulfilling our request. And within this backend and the front end service, means between the client and the backend service, there is one more important thing that actually exists for a distributed architecture system, that is the load balancer and the API gateway, which takes the traffic from the client and distribute it uniformly across different backend services. I hope this is clear, and this is a very basic high-level architecture of any application that we have right now. So here we are having the client, and client is doing a request to our backend, and the request is first going into our load balancer and the API gateway. And once the request comes into the load balancer and the API gateway, what this API gateway and the load balancer will do, based on the URL endpoint, the API gateway will route the traffic to the corresponding backend service, and the responsibility of the load balancer, that is based on the number of replications or the instances of the particular backend service we have, it distributes the traffic uniformly across all the services so that the services handle the traffic uniformly. So this is basically nothing but a high-level designing of any application or any microservice application that exists for the user. Now let's see in this entire architecture where the rate limiter actually lies. Now if you understand the property or the functional requirement that we have to solve using the rate limiter, that is, we have to restrict the user, or we have to put a limitation on the usage from a particular resource. And to fulfill this requirement, the first idea that comes in our mind, that is, we will restrict the user at the very starting phase where we are generating an event. And where we are generating an event, we are actually generating the event on the client side. So for example, we are having a buttons which is actually creating the event or calling our backend API. So since the button is the first point of contact for the user by which the event is getting generated and we are hitting the backend, so the first idea that comes like, we will block the user there only. Means if the user clicks the button for 10 number of times within a particular minute, we will just disable the button, or we will implement some different algorithm or different way to restrict the user from using our backend application. So what we can do, the first way is, we will put a rate limiter over here on the client application, and we will restrict the user or the client directly on the first side, and that is on the client application. Clear? So this is one way how we can place, or where we can place, the rate limiter in our entire system. But there is a problem with this application, because whatever logic we write on the client side is very much vulnerable. Means it can be easily hacked by the front-end user, and it can be easily changed. So for example, what we can do to implement this rate limiter, we have to set a counter in the local cache or the local cookie of the client. Clear? And as you know, the client cookie and the cache can easily be altered or deleted. So it is not a brute force way to implement a rate limiter. So though it is a feasible solution to put a rate limiter at the very beginning, means at the client side, but it is not a brute force solution for our use case. Clear? Now the next place where we can easily place our rate limiter is on the backend service. So for example, here if you look carefully, we have multiple backend services. And for example, this backend service is used for generating the image. Thereafter, here we are having another backend service which calls some of the LLM or anything, and it is responsible for generating the text response. So this is one of the backend service. And our use case is, for a particular free tier user, we have to restrict the user for 10 requests per minute. Means for the image creation, we have to restrict 10 image creation per minute. Means a user should not be able to create 11 images within a particular time window. Clear? Now for the second use case, it is different. That is, for the generation of the text, we are giving or allowing 100 conversation per minute. So on a single application only, we have two different use case of the rate limiter. One is like for the image generation, we are only supporting 10 images per minute, whereas for the text conversation, we are just restricting the user for 100 conversation per minute. So here for this use case, what we can do, we can keep the rate limiter per service. Means for this backend service, we can place a rate limiter over here. Similarly, for this backend service, means for the text generation, we can also put the rate limiter within this backend service. Clear? So here what we are doing, for each and every backend service specifically, we are creating a rate limiter and we are restricting the user from using the application. But here also there lies a problem. That is, what we have done for this particular service, we have implemented or we have introduced our rate limiter. But here if you look carefully, the amount of requests that we are getting or amount of requests that we are supporting for this type of application is quite huge. So obviously it's quite understandable that for an application like ChatGPT or Gemini, the amount of load or the request per minute goes to a million, and it is not possible for a particular server to handle that much amount of traffic. So it is not possible that only a single instance of the image generator can handle that amount of peak traffic. So obviously to handle that, what we have to do? We have to do multiple replication of the same instance. So for the image generation use case, obviously there will be thousands and thousands of replication of this single application. Now with introducing multiple replications on a server, we have created another problem. That is, we have created the problem on the rate limiter. Because earlier what we were doing, we have kept the rate limiter within our backend service. Now since right now we are having multiple replication of the backend service, so obviously we are having multiple replication of the rate limiter on each and every backend service. So you can easily understand that with the introduction of so many rate limiter on each and every service, there will be a miscalculation in the rate limiter, because it can easily happen that I as a user on the first instance have used the first instance of this backend service for generating my first image. So there is a counter that tells that I have used the image creation service only for once. Now on the second request, which I am doing within the 5-second window or within the 10-second window, it can happen that that second request will go into the second server or the second replication of the image creation service. So there also there will be only a single update. This user is using this application only for once. So here for both the entities, means both the replication, we are having the separate usage number on its local. So you can easily understand that we are not making these things as a global parameter or a global variable by which we can track the usage limits. And that is why it is actually a problem to implement or introduce a rate limiter within a particular backend service if the backend service have multiple replication. I hope you are clear with why it is very difficult to maintain such type of scenario. But the thing is like, it is not that it is not feasible. You can easily make that thing possible just by keeping that value or keeping the counter in some global memory or some global storage system. That can easily be done. But based on our use case, we might have to follow this path. But there is one more way we can use or we can easily place rate limiter in our system so that it fulfill all this use case or it can solve all this purpose. And that is putting the rate limiter on the system or the module where the actual request first comes in. Means here in the load balancer and the API gateway. So here normally or generally what we does, within this API gateway, we put the logic of the rate limiter. So this rate limiter is nothing but a process or a logic that resides within this API gateway. So here as you see, I have told you 3 ways by which you can put the rate limiter or 3 places where you can place the rate limiter. Number 1 is within the client, number 2 within the backend system, and the number 3 is within the load balancer and the API gateway. And among the three of them, the most commonly used way of keeping the rate limiter is the third one, and that is keeping the rate limiter, API gateway and the load balancer all together at the very starting phase of our application, and that is over here. Let me just draw this picture clearly so that it will be easy for you to understand. After that, we will see in detail that how a request comes from the client, goes to the load balancer and the rate limiter, as well as the API gateway, and finally goes into the backend service. So let me just first clear this design. So here if you see, I have put the rate limiter over here within the API gateway. But as I was telling you, this is not the only way to deploy a rate limiter in our system. There can be many places within our entire distributed architecture where you can place the rate limiter based on your requirement. And I have discussed the top 3 ways which is most commonly used in the industry. But there are other ways also by which you can deploy the rate limiter in our distributed service. And these are some of the places where you can actually place. So it is on the client side, you can put the rate limiter on the reverse proxy, the API gateway, or you can put it as a sidecar. Also, you can keep your rate limiter within your backend microservices. Also, in a huge system or a big system, you can have a dedicated load balancer as a complete microservice which will have a dedicated deployment process. Also, you can put the rate limiter as a layer before your database. So there are multiple ways by which you can put or introduce a rate limiter within your system. Only thing that you have to achieve, that is, you have to limit the user from abusive use of the system, and to achieve that you can deploy it wherever it is required. But in most of the cases, in most of the use cases, rate limiter logic can be deployed either as a part of the API gateway in the form of a plugin, middleware, or as a filter, or you can keep it as a separate rate limiter service. So that is totally your choice. But in both the cases, whether it is deployed within the gateway or it is there outside the gateway, but the gateway is usually the enforcement point, because it will intercept the request coming from the client and thereafter do the validation, and thereafter if the validation or the check pass, it will bypass or it will forward the request to the downstream application. So I hope you are right now clear with how to deploy or where are the places in our distributed architecture where we can actually place a rate limiter. Clear? Now I will just give you a small flowchart like things so that it will be clear for you to understand that how a request first comes into our service, how it gets through our load balancer and the API gateway, and then it goes into our backend service. So let me just introduce the flowchart over here. So here you can see this is how the data flow of the rate limiter actually takes place. So the request first comes from the client, thereafter it comes into our load balancer, and from load balancer the request goes into the API gateway, and within this API gateway, since our rate limiter is deployed as a plugin or as a middleware, so the first thing that happens is like the API gateway do its first operation, that is the authentication check. And once the authentication check is done, then what it does the rate limiting operation, means it calls the rate limiter service, and here the rate limiter takes the decision that whether the incoming request is a valid one or not, means whether it fulfills the requirement or not, and thus the policy check and everything within the rate limiter is done. And if the client or the request is qualified for the request, then what will happen? The rate limiter will give a boolean in the response, means it is allowed, means the request can go into our backend service, and if it returns false, means the client have exhausted its request within a particular time frame, then we will respond the client with 429 as HTTP status code. I hope this clears the doubt that how the request first comes into our load balancer, do all the validation, do all the pre-checks, and compute that whether the request is a valid request, whether the requests have exhausted quota or not. And once everything is done, thereafter it takes the decision that whether the request will pass to the downstream application or we will return a 429 error message to the user. So I hope this makes the things a bit more clear. Now, as you have seen that we have more or less covered whatever the things that are required for the HLD round. That is the idea of how to deploy or which is the perfect place where we can place the rate limiter. Now comes a major problem, that is what we were discussing earlier, that is in case of the distributed system, how we will configure the rate limiter. Because here also, if you understand it correctly, for a huge distributed architecture or a distributed system, the number or replication of the API gateway or the load balancer will also increase. It is not the only instance that will handle all the traffic. So if we increase the API gateway in the system, so obviously the instances of the rate limiter will also increase. And if that thing happens, you can easily understand we will again fall into an issue, that is the counter mismatch. Means, for example, for a particular user, we have a counter set on the rate limiter 1. Now, if the next request goes to the next rate limiter, then a new counter will start on that API gateway, which will create an inconsistency within the rate limiter. And to resolve this issue, what we have to do, we have to keep the counter of the rate limiter outside the system. So here, if you understand it clearly, here we can have multiple instances or multiple replication of the load balancer and the API gateway in this complete architecture. And since this is also increasing, obviously the number of rate limiter is also increasing. But all the counters and everything that we have, which keeps the count of the total number of requests a particular user have done within a period of time, all this information we have to keep it outside in a separate global space. And that is why what we need here, we need a global cache or a global storage unit. And for that, since a rate limiter should act with nominal latency, so here there is no other option than to introduce a caching mechanism like the Redis cache. So here we will be having our Redis cache into our system, and all the counters and the states and the values that this rate limiter is having, we will store it in this global cache, that is this Redis cache. I hope this is clear that how we are enabling the rate limiter for our distributed architecture. Now the next important thing that we have to implement, that is here, if you look carefully in the functional requirement, we have taken a requirement that the rules and the configuration of the rate limiter should be configurable by the admin. Means it is not a static rule or a static data on which we should operate. So obviously we have to give a provision for the admin to change all this data. So what we will do here, we will introduce a small service called as a rate limiter policy service. So let me just introduce this service over here. After that, I will tell you what this service will actually does. So here I will introduce one more service called as a rate limiter policy service. And the responsibility of this service is actually handling all the APIs endpoint that we have configured or we have listed over here. So whatever the data, means whatever the policy the admin want to create for the users or for the client, all these things, all this operation, the CRUD operation will be taken care by this rate limiter policy service. And since here the admin is creating the rules and want to save these rules for the client or the user, obviously here we need a storage for that. So what we will do here, we will introduce a database for the rate limiter, and let's call it as a policy database. I hope you are clear with why in the rate limiter we have introduced a separate service called as a policy service, and we have introduced a database called as a policy DB, because here we have taken the requirement into consideration that all the rate limiter rules should be configurable, and that is why here we have this service. And how the request will land into this service, it will come via this API gateway that we have defined over here. So actually the admin of this application will invoke this service over here, and it will simply save the information of the client or the user within this policy DB. But now if you look carefully, there is one more problem, that is whatever the information the admin is saving, means the rules and the policy are stored in the policy DB, and there is no correlation or there is no relation between the Redis cache and the policy database that we have over here. Means the rules and the configuration, though it is getting changed by the admin, but it is not getting reflected within this Redis cache on which this rate limiter is acting on. So here what we have to do, here we have to go with the concept of the write-through approach. Means first the data or the policy will get created in this policy database, means it will get persisted in our system, and thereafter we will update this Redis cache that we have over here, so that all the rules and the policies on which this rate limiter is acting on remains updated. But obviously, as you understand, since this is a two action that is taken place, so obviously there will be a latency within the system, and that is why here at the very initial stage we have taken this non-functional requirement, and I have told you while discussing the cap theorem that here the system requires high availability rather than consistency, because here you can see there is a latency in propagating the data from the policy DB to the Redis cluster. So it is not a high consistent architecture, rather a eventual consistent system. I hope this is clear that how we will be designing this rate limiter in this entire distributed architecture. Now let's see what will be the database that we will be choosing over here and what will be the schema structure of this policy database. So here if you understand it clearly, this policy database or the policy DB is actually a flat relational database, because here we just need to save some structural configuration. So obviously here we have to keep some relational database, and for that we will be using a Postgres DB over here. I hope this is clear. So this will be our Postgres database. Now let's see what will be the schema structure of the database, which will store all the schema or the policy of the user. So this is more or less how the schema structure will look like. So let's go through it one by one. So here you can see, here we are having a rule table, and here we have a primary key called as a rule ID. And thereafter we have a subject type, which will give an idea that on what type we are setting the rule. So as I was telling you, a rate limiter can be configured on a particular user ID, on an API key, on a particular IP, or it can be many criteria or parameter on which you can restrict the user. So that comes as a subject type over here. Number two, here we are telling that whether for a particular user ID we are setting the rule or not, whether for a particular API key we are setting the rule or not, or it is for the premier customer or a free customer. So based on whatever the structure or whatever the parameter, how you want to configure all those data, you can keep it within this two field, that is the subject type and the subject value. And this makes the configuration much more dynamic and solve all the use cases that are most commonly used in the industry. Now the main thing is like on which endpoint we are actually creating this rule, and for that we have the next attribute that is called as an endpoint, where you have to set the URL on which you are providing this use case or providing the rate limiter. So if it is for the entire application, you can simply put it as a star, means it is applicable for all the endpoints, but if you have a specific endpoint, you can also mention it over here. I hope this is clear. Now comes the main thing, and that is the algorithm, which we have not discussed until now, but we will be discussing it very soon. So the another important attribute, that is algorithm. Now the next important parameter is the request limit, means how many limits you want to set for this particular condition, what will be the window size, and all other configuration that are needed for creating a particular rules of the rate limiter. We will be saving over here in a single table called as a rate limiter rule. I hope this is clear that how we are persisting the configuration within this policy DB, and once this is persistent, how with the help of the write-through approach we are updating this Redis cache over here. Now since you have got an overview of how our rate limiter actually works in a system, now let's do a deep dive within our rate limiter and let's see how it actually works and how all this configuration and everything that we have saved are used by the rate limiter. So let's go into our next phase of development or the next phase of the design, and that is the deep dive designing of the rate limiter. So that will be our fifth step of our design. Before proceeding further, I just wanted to notify that I have created a very simple website over here so that you get all the contents that I upload on the YouTube on a single platform. So here you can see there are lots of content on the system designing, on the low level system designing. Similarly, here we have the complete graph playlist where we have already 15 to 16 video over here, as well as all the latest contents that I'm uploading on the YouTube. I will keep on updating all those things in this website. This is a free website that is hosted also in a free domain. So do not forget to bookmark this website so that it will be helpful for you to find out all the relevant contents regarding your upcoming interview. So on a very high level, rate limiter is nothing but an algorithm which works on some of the principles and the configuration that we have saved over here within this database. And taking all this configuration, the rate limiter, what it does, it runs few of the algorithms within its process, and it simply filter out the request based on this rules and configuration that is set for the particular user or a particular client. And there are 5 most commonly used algorithms the rate limiter actually works, and the algorithms are: number 1, the fixed window counter; number 2, sliding window log; number 3, sliding window counter; number 4, the token bucket; and number 5, the leaky bucket. So these 5 algorithms are the most important algorithms which are actually used internally by our rate limiter to filter out all the requests coming from the outside world. So I hope right now you are clear with how a rate limiter actually works internally. So it is nothing but a simple logic or a simple algorithm by which it actually does all these things. And it is very important for you to know that how this each and every algorithm actually works, and which is the best algorithm which is most commonly used in the industry for implementing the rate limiter logic. Because during your interview, what you have to do, first you have to explain on a very high level that what are the algorithms that are mostly used in the rate limiter, and thereafter what you have to do, you have to tell the interviewer that according to you which is the best algorithm which is brute force and can be used to solve all the problem. And then once you are done with this discussion, what your interviewer will tell, your interviewer will tell you to write this algorithm from the scratch using some object oriented design pattern. So that is the main intention or the main steps that you have to follow while solving this problem during your system designing interview. I hope this is clear. So before we step into the best algorithm or which is most commonly used algorithm in the industry, let's first do one thing, that is we will go through each and every algorithm, and let's first see that how each and every algorithm will work internally, what is the internal behavior, and let's compare one algorithm over another, and let's understand these things a little deeper. And to understand this algorithm more intuitively or visually, what I have done, I have told ChatGPT to actually create a website where we can visually see that how each and every algorithm actually works internally. So here if you see, this is the UI page that I had generated with the help of the ChatGPT. So here we have the 5 most important algorithm, that is the fixed window algorithm, the sliding window log, the sliding window counter, the token bucket, and the leaky bucket. So let's start with the first one, and that is the fixed window algorithm. So before going into the fixed window algorithm, let me tell you what this algorithm actually tells. So as the name suggests, fixed window algorithm tells that what we are doing, we are distributing that entire time frame into fixed windows. So let's take an example. This is our timestamp, and here what we are doing, we are creating a fixed window size of 10 seconds. So for example, this is our first window. We start from here to this point, means this is our first window. Then comes our second window, that is from 10 to 20 and so on. So in this way, we will be having different window of fixed size of 10 seconds each. And the problem statement or the configuration of this algorithm is like, we have to define the value of the total number of requests that are allowed within this time frame. So for example, we have configured that 10 requests will be allowed within this 10-second window. So the value of n will be 10. I hope this is clear that what does this 10 means? Means we are allowing 10 requests within this time window. Clear? Now with this idea in mind, let's now go through the demo. So here if you see, this is the fixed window counter algorithm. And here if you look carefully, there is a counter that is running. And if you see, the counter is set to 10. Means after each and every 10 seconds, this counter is getting reset. Means it is going back to 0 second. And here if you look carefully, there is one more variable that is called the maximum request, which is set to 5, which means that within this time frame or within this window size of 10, only 5 requests are allowed. Clear? Now if the 6th request comes in the time window of 10 seconds, what we will do? We will simply reject that request, or we will drop that request, and we will send a 429 response to the client or to the user. Clear? So that is the main crux of this algorithm. So let's see with our demo. So here if you see, I have a button called a send request, which actually mimics that how the client is sending requests to the back system or to the API gateway. So if I click this button, here you can see one of the requests came into our system, and here if you see, after the 10-second window expires, this request counter goes back to 0, which means that here we have a counter which stores that the total number of requests we have got within this time frame or within this window size. So once the time window expires, this counters over here also gets expired, and we get a completely new time window or a new time frame where all the requests can come in. So here if you see, within this window size of 10, if I click this button 4 to 5 times, all the requests will go through, means it will give a green signal. But if the counter exceeds more than 5, it will come into this block state, and the counter of this block 1 will increase, means we are dropping those requests of the client. So here if you see, at the starting of the window, if I click this button 5 times, all the requests went in, means our rate limiter allowed all the requests. And once it goes to 0, our counter again got reset, and again on the next window it will allow 5 more requests. But if I give any value or any request more than 5, let's see what happens. So here if you see, if I go beyond 5, you can see this request is getting dropped and it is going in the block state, means it is not allowing any request beyond 5. I hope this is clear that what this fixed window counter actually means. So very clearly, you cannot pass more than 5 requests within this time window of 10 seconds. And once the timestamp on the window expires, a new counter begins over here, and it is a fresh start where it can again accept 5 more requests. Clear? So this is the main algorithm what this fixed time window actually says. But here there is a problem with this algorithm. So here if you see, this is very simple algorithm to implement, because you just have to keep 2 variables, one as a counter and another as a time frame window. Clear? But the main problem is like here this algorithm cannot support a burst load, means for example, so here we are having a 10-second window, means after this 10 second the window is getting reset. But if suddenly all the requests comes in at the 9.9 second, here we are supporting all the 5 requests over here. But as soon as the time window goes beyond 10 seconds, means another counter comes in and get reset with 0, means we are allowing again 5 more requests over here. Means here at 9.9 second, we got 5 requests. Similarly here at 10.1 second, here another 5 requests we are accepting. Means within a span of 0.3 second, we are actually supporting 10 requests, which is not what we have said in the configuration, because our main purpose or the main logic was to uniformly handle all the load and to support the burst load. Now since we are not going with the fixed window counter, let's see what can be the better approach to this problem. So the main problem of this fixed window counter is like the edge cases, because over here if you have understood that at the edge of the window, means where the window is ending and a new window is opening, over there if we get a burst traffic, then the calculation of the total number of requests that we are accepting on a particular window is actually violating, because with this algorithm it is actually allowing more than the number of requests that we have set on a particular window. So that was the main problem that we were getting on this algorithm. So to solve this problem, what we can do, instead of making these windows as a fixed size or the fixed starting point, what we will do, we will make it as a sliding window or a rolling window, so that with time the window will also slide together and it will try to calculate that what are the requests that are coming on a particular sliding window. And with that logic, we have our next algorithm that is called as the sliding window log. So as you can understand by the name of the algorithm, it is called as sliding window. So as you have solved in the DSA, we have multiple problems on sliding window protocol, and here also we are doing the same thing. That is, instead of hard coding the window from 0 to 10 and from 10 to 20, what we are doing, we are keeping a rolling or a sliding window, and here we are calculating that while the window is moving, at that time how many requests are there within that time frame or within that sliding window, and based on that we are calculating that whether the request will be allowed by the rate limiter or not. So let me just give you a demonstration that how it is implemented and what I'm actually meant to say. So here if you look carefully with the sliding window protocol, what we are doing to implement that, here whatever the request that is coming into our application or into our API gateway, we are basically keeping it in a queue, or we are just keeping the track of at what time the request came in with a timer associated with it. Means for example at the 0th instance a request came in, so we are attaching a timer with that request that at 0th second the request came in. Now on the next second if another request comes in, what we will do, we will start another timer associated with that request, and in this way just by keeping track of the timer when the request came into our API gateway, what we are doing, we are actually implementing a sliding window algorithm, and once the 10 second of a particular request get expires, we are removing that request from our window. Basically what we are doing, we are keeping a track of all the requests that are there within that time frame of 10 seconds or whatever the size we have defined for that window. So let me tell you with the example that how it is implemented. So here if you look carefully, whenever a request come into our API gateway or into our rate limiter, we are associating a timer into it. So this is nothing but the time duration for which this request can be kept in a particular queue. And here since the window size is maximum 10 seconds, means a particular request can be kept in the queue for only 10 seconds, and once the 10-second window expires, we are simply removing that request from our queue. And in this way, with this logic, we are implementing a sliding window concept, and we are just checking that the total number of requests that are within this 10-second sliding window or the rolling window, whether it is within the limit of the total number of maximum requests that we are allowing or not. And if it goes beyond the maximum request, what we are doing, we will simply drop that request and we will tell that this rate limiter will not allow any more requests for this sliding window. I hope this is clear. So here if you just look at the algorithm clearly, here if you see what we have done, we have defined the sliding window size as 10 seconds and we are allowing 5 maximum requests within this sliding window. So what we are doing here, if you see, if I click this button 5 times, means that the total number of requests that we can allow within this 10-second window is 5. And if I click one more request, then what we will see? We will see that the request will get rejected because on that sliding window already 5 requests are already there. And once the first request that came into the sliding window get expired, after that only a new request can come in. So here look at this demo carefully. So here if you see, I am clicking this button 5 times and here if you see, all the 5 requests got accepted. Now if I click on one more time, here you can see the number of block requests is getting increased. Means we are not allowing any more requests within this sliding window of 10 seconds. But here if you look carefully, once the first request expires, then after that we will be again allowing one more request or further request. So here just look at this use case. So here I am clicking this button for 5 times. Now just see, once the first request gets expired, then we can click one more time and here you can see we are accepting further request over here, and in this way we are creating the logic of a sliding window, and whenever the request goes beyond that sliding window, we are dropping that request from our window and we are giving the provision or we are allowing further requests to come in within that window. I hope this is clear that how the sliding window algorithm actually works. But the main problem with the sliding window log is like the consumption of the memory and the way we are actually implementing this logic. Because if you understand this logic, on each and every request, we have to keep track of at what time the request came in, and we have to keep a counter over there, and also we have to put that value or keep that request in a queue. So there is a lot of memory that get associated on each and every request that comes within our API gateway into our rate limiter over here. And that is why, since the amount of management or the memory management becomes quite huge, that is why we cannot implement this algorithm to solve the production level problem. Because in the production level, you can easily estimate that there will be millions of requests per second, and if we keep track of all the million requests with some time associated over there, and if we keep it in a queue, then there will be a lot of memory that will get associated and our system will become damn slow. So it is not possible to manage all this time management activity, and also it is very difficult to evict a particular request once the time frame or once it is moved out of the sliding window. So all this logic or the algorithm though is very good to implement or fulfill all our use cases, but it is very difficult to manage, and that is why normally for a high scale application we do not implement the sliding window log algorithm in the production or in the real world use case. I hope this is clear that what this sliding window logs actually tells. Now let's see how we can solve this problem. So the main problem of this sliding window log was management of the resource, since we were associating timers, logs and everything on the API gateway or at the rate limiter. And to optimize this even further, we came out with the next algorithm, and that is called the sliding window counter. But the logic or the way the sliding window counter actually works is more or less the same how the sliding window logs actually works. Means it is also on the concept that there will be a rolling window which will go with time, and we will just keep track of how many requests that came in within that particular sliding window. But the only optimization that we have to do over here to resolve the problem that we were facing with the sliding window log, that is, we should not keep track of all the requests with the help of a time tracker, or we cannot put it in a queue because it was consuming a lot of memory. And to optimize that, what we have done, we have removed the concept of this time tracker and we went into some deterministic algorithm, or we have made a new algorithm with some deterministic assumption. So let's see what this sliding window counter actually means and how it is implemented. So here if you look carefully in the sliding window counter, what we are doing here, if you see, there is some computation that is going on over here. Now first let's understand that how this thing is actually working. So the concept of the sliding window counter is actually quite easy if you just understand it logically. So what we are doing over here, so for example, we have a timeline of 0 to 20 seconds. So this is the total timeline on top of which we will be implementing this algorithm. And here let's take an example. The size of this sliding window is also 10 seconds. And so here we will be having our first window that is from 0 to 10 seconds. Clear? And the value of n is equal to 5. Means we are only allowing 5 requests per sliding window. So on the first frame or first 10 seconds, let's assume that we got all the 5 requests over here. This is 1, 2, 3, 4, 5. So these are all the 5 requests that came in within this sliding window. Now let's take an example that our sliding window moves a bit. So for example, another new request came into our API gateway or into our rate limiter at the 12th second. Clear? So this is on the 12th second and a new request that came in over here. Now since the request came at the 12th second and since the size of the window is 10 seconds and the concept is sliding window, means right now the window is standing from here to 12 second. Means our sliding window right now starts from the 2 second to 12 second, which is also a 10 second window. I hope this is right now clear. Now what we are doing in this algorithm, we are doing a deterministic assumption. Means here if you look carefully, just to determine that whether we should allow this request at the 12th second or not, what we are doing a calculation. This is the total length of the sliding window, and here in this window we have contribution from both the window. Means here we have a contribution of 80% from the previous window, and here since it's a new window that only passed 2 seconds, so obviously it will be a 20-second time window. So this is the first assumption or the first thing that you have to understand. Now with these two numbers, we are actually will be determining that whether the new request that is coming in, whether we should accept it or not. So what we are doing here, we just only take an assumption that whatever the request that had came in our previous window have came in a uniform manner. With this assumption, what we are doing, we are just dividing this window into parts. Means here if you look carefully on the previous window, we have 5 requests. And since our new sliding window have a contribution of 80% from the previous window, so what we will assume that since the previous load was uniform, we will take the assumption that the new sliding window that is getting created right now will also have the same impact. Means we will take 80% of the previous sliding window now on the new window that is getting created. Means over here right now we will first calculate that how many requests that had already came over here. So here if you look carefully right now, between 0 to 12 second, means within this 2-second window there is no request that came in. So the total number of requests that we have already accepted is 0, and the 20% of 0 is also 0. So this is how we are doing this calculation. So here if you look carefully, 80% of 5 is 4, and here 20% of 0 is 0. Means within this new sliding window that got created, we will assume that the 4 request is already there. Now since a new request is coming at the 12th second, means the total number of requests that will come on this sliding window will become 4 plus 1, that is 5. And since this is within the total number of requests that we are accepting, means we will accept this request that is coming over here. Means we will allow this request to come in. I hope this is clear that how we are calculating this thing mathematically with the help of some weightage logic. And here in this entire logic, you can easily understand that there are a lot of assumptions that are making. That is the first primary assumption that we are making, that here the total number of requests that came over here are uniform, because until and unless this uniformity is not there, we cannot tell that on each and every parts of the second what had actually happened. And if here the load or the traffic is not uniform, then also this algorithm does not work properly. And since this entire algorithm is based on assumption, so though it is very good algorithm to implement, but we cannot tell definitely that the maximum number of requests that we are allowing will be 5 always, or whatever the number you are setting. I hope this is clear that on what calculation we are actually implementing this logic. Now since you have understood that how this algorithm is actually working, now let's see the demo that what is happening over here. So here if I just give a demo of what we were doing, so let's take an example that on a particular window that is getting created over here, we are allowing 5 requests. So what I will do, I will just create 5 requests over here. So here you can see we are allowing 5 requests. Now once the next window will start, you will see that we are making an assumption that the 50% or the 60%, that rolling window, we are making a percentage of the total number of requests that we have already allowed. And based on this calculation, we will determine on runtime that whether the request will be allowed or not. So here you can see we are allowing the request over here, and whenever it goes beyond, we are just restricting the request for this sliding window. So there is a small problem with this algorithm, that this is not a optimal solution, means it is not giving you the precise answer, rather an assumption or a deterministic assumption on which this algorithm is entirely created. So if you understand this algorithm, this is actually a better algorithm than the sliding window log, because here we are not allocating that much amount of memory, because here we do not have to keep track of all the counters and the duration of the request. Rather, with the help of a simple mathematical logic, we are just computing all the things. Now comes our two major important algorithm, and that is the token bucket and the leaky bucket algorithm. So far we have discussed 3 of the algorithm. One is the fixed window, number 2 is the sliding window, and another is the sliding window counter algorithm. But during the interview, the most commonly asked question is on the token bucket and the leaky bucket, and it is expected that during your interview you should be able to explain both of them clearly, because believe me, during your interview you won't be having that much amount of time to explain all the algorithm. Then what you should do, simply tell your interviewer that to implement the rate limiter we commonly use 5 algorithms, and you just simply name all the 5 algorithms, and thereafter your interviewer will definitely give you a counter question, that is, among these 5 algorithms which of them you think are the most suitable for the production level use case. And thereafter and there only you tell that the most commonly used algorithm in the industry are the token bucket and the leaky bucket, and thereafter what you do is simply explain the complete architecture or the complete implementation or the working principle of these two algorithms, that is the token bucket and the leaky bucket. And once you are done with that, then only you start with writing the code of one of them. Now which one to choose, that I will tell you very soon. Now let's start with the understanding of the next algorithm called as the token bucket algorithm. So if you look carefully, the visual representation of the token bucket, it will be very easy to you to understand the algorithm. So here if you look carefully, what we are doing to implement the token bucket algorithm, we need 3 variables. Number 1 is the capacity of the bucket, means the total number of requests we are supporting. Number 2, the refill rate, means how many tokens can be put within this bucket. Number 2, cost of the token per request. Normally we set it 1 by default. So these two are actually the main 2 variables that we have to keep track of. Now let's understand what this algorithm is actually telling. So this algorithm is telling, like, here you have an empty bucket, and what is happening based on the value of the refill that you have set, means you want 1 token to be refilled per second, this counter will get fulfilled, and there is a maximum cap to this bucket, means here you can see the capacity is set to 10, means this bucket cannot get overflowed, so there will be maximum 10 tokens that it can handle within this bucket. Clear? Now what will happen, once a request comes into your bucket or into your API gateway, what we will do, the request will come into your API gateway or into your rate limiter, and it will consume 1 token out of your bucket. And in this way, as soon as some request is coming in, it will simply consume 1 token from the bucket and it will go to the backend service. And this process will keep on continuing until your bucket is empty, means once your bucket is empty, means we have consumed all the tokens and we have to wait for further token generation. And what is the speed of the generation? That is 1 token generation per second. And if any request comes in when the bucket is empty, then all those requests will get dropped and we will send the 429 response to the client. I hope that is clear that how this entire architecture or entire designing is made. Now let's understand it with the help of this demonstration. So here if you see, if I click on this send request, one of the token is getting consumed on each and every click, and here if you see, on each and every second another token is getting fulfilled. So there is 2 flow that is getting involved, that is a request is coming in and it is getting consumed. Also there is another flow, that is the refill rate of the token. So both of the flow are getting created or getting initiated simultaneously within this bucket, and we are managing the tokens within this bucket. So if I just quickly give you a demonstration by consuming all the tokens over here at a single burst, it will be very easy for you to understand that how the token generation is taking place and how you are consuming the token. So what I will do, I will click this button 10 times in a burst, means all the requests will come in this bucket at the same time or more or less at the same time. So let me click it 10 times over here to consume all the token. So here if you see, I have consumed all the token. Now if I go beyond this bucket size, means if I have consumed all the token, if you see, I am clicking the request multiple numbers of time, but since the number of token is now 0 in the bucket, all the requests are getting blocked over here, means no further requests are allowed by this system. Clear? Now if I stop requesting or stop sending requests to the backend service, what will happen? The token generation will start as 1 token per second. Clear? Now here if I again click on the backend service, means 1 token will get consumed over here. I hope this is clear that how the token bucket service or token bucket algorithm actually works. And if you understand this logic, it is very brute force logic, and with the help of this logic, you can not only consume the token in a systematic manner, also it support the burst load or the burst traffic on our backend. I hope this is clear that how we are generating or how we are implementing this token bucket algorithm. Now let's go into our fifth algorithm, and that is the leaky bucket algorithm, which is more or less on the same concept how the token bucket is also implemented. But the only change that is there, that is here, if you see, we have a queue size that we have defined over here. So in the token bucket, what we have done, we have defined a bucket, but here what we are doing, we are introducing a queue mechanism. Means whatever the requests that are coming from the front end, we will simply place the request in the queue, and in the logical or a uniform way, we will be processing the value from the queue or processing the request from the queue. So it is more or less the way we implement the CDC pipeline. Means whatever the request that is coming from the user, we are simply putting it in the queue, and there is a consumer service who are actually consuming the data from the queue. And with that logic only, this leaky bucket algorithm is actually working. So let me just give you a demonstration of this. So here, as I was telling you, here you can see size of the queue is 8 and the drain rate per second is 1. And what is this value? This means that what will be the uniform rate by which the request will get consumed from the queue. So for example, there is a burst traffic that came into our server. What will happen? There will be multiple requests that will come first in the queue. So here if you see, there's a lot of requests that are coming in the queue, but the consumption of the request from the queue is taking place in a most uniform manner, that is one request per second. So here you can see how we are generating this algorithm. Means once the request comes into our server, we are just keeping it in the queue, and thereafter based on the rate that we have defined over here, the consumer will consume the request from the queue. Now, the problem with this algorithm is that here, if you understand it logically, we are using a queue to implement this algorithm, and whenever you are introducing a queue, there will be a problem of the latency, because whatever the request that comes at the last of the queue, that request have to wait till all the requests that came prior get consumed. So there is a small bit of latency that gets created with this algorithm of leaky bucket. So I hope you got complete understanding of how the leaky bucket algorithm actually works. But on which of the use case we should use the leaky bucket? Only when our backend service demands an uniform rate of consumption of the traffic. So for example, we have a delicate backend service which only demands the request in a very systematic or a uniform manner, then only we should implement with the leaky bucket, because otherwise there will be a huge lag in the queue and all the requests will get dropped. I hope this is clear. So now, since you have understood all the 5 algorithms that we normally use in our rate limiter, now I think you are in a good shape to understand that among all these 5 algorithms, the token bucket is the one that is most commonly used in the industry, because this allows a systematic way of the request traversal, and it is very much burst friendly. Now, once you tell your interviewer that how this 2 algorithm works and why you feel that the token bucket is the best algorithm to solve all the use case in the production, then what the interviewer will tell? The interviewer will tell you to write the code using some object-oriented design pattern. And here, if you understand this correctly, the design pattern that we should use for the rate limiter is nothing but a strategy design pattern. Because if you understand this rate limiter as a whole, you can see that what we can do, all this logic or all the algorithm will become one strategy, and dynamically during the runtime you are determining that which strategy you should use to implement the rate limiter. So let's see how the code of the rate limiter algorithm will look like and how we will be implementing it with the help of the strategy design pattern. So here, if you look carefully, what I have done, I have written the entire code and I will upload it in my website. So do not worry about the code what I have written. It is simply copied from ChatGPT. But what we have to do, you have to simply understand that how it is working and how we are implementing the strategy design pattern over here. So here if you see, this is the starting point of our code, that is the main block. And here if you look carefully, what we are doing, we are first initiating the rate limiter type. And here if you see, we are going with the token bucket. So here this token bucket is nothing but the configuration that a particular admin have set for a particular user. So this is nothing but the configuration that we are getting from the database or from the cache. Now once we got the idea that we are going to implement the token bucket algorithm, what we have to do, we have to first create an instance of that strategy or instance of that algorithm. And for that, what we are doing, since we are going with the strategy design pattern, means on the runtime we are first creating the object of the token bucket. So here if you see, here we are having a rate limiter factory, which is nothing but returning the object of the token bucket. So let's first understand that how this rate limiter factory is defined. So here if you see, we are having the rate limiter factory defined over here. And since here we are passing token bucket as the parameter over here, so what we are doing, we have written a switch case. That is, once we get the value as the token bucket, we are returning a token bucket object over here. And in the parameter, we are passing two things. That is, number one, the total number of requests that we will be allowing within this sliding window, which is nothing but the n, and some of the value that is required over here to drive this algorithm. So for this token bucket, what we have to do, we need the last timestamp at which the token got created. And that is why we are sending this as parameter. So what we are doing till now, we have first created an object of a token bucket. Now what we are doing, once we have got the token bucket as a strategy, the next thing is like we have to invoke that strategy. And how we are doing, we are having a gateway or an API gateway, and here we are passing this strategy that we have got from the configuration. And what is the strategy we are passing? We are passing an object of the token bucket. Now let's see how this API gateway is actually working. And here if you see, we are having a rate limiter strategy, and here we are initiating this variable over here, and based on the strategy that we received as a parameter, we are just invoking the method of that strategy, that is nothing but the allowed request, which means that whether for that strategy the request that came in, whether it is allowed or not. And since here we are passing the token bucket, so what will happen, this token bucket limiter or this implementation will take place. Means here we are implementing the complete logic of the token bucket, and we are checking that how the bucket is creating and all the logic what we have understood right now. So how the logic is implemented is not at all important right now. You can easily go through the code and you can understand it line by line that how it is implemented. And here you can see I have given the code of all the algorithms, that is the fixed window, sliding window log, sliding window counter, token bucket, and the leaky bucket. So I hope you guys have thoroughly understood this video and you have found this video useful. And if you have found this video useful, do not forget to like, share, and subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So see you in our next video where we will be solving another problem statement on system designing interview. So see you in our next video. Thank you.